Hi everyone, it's Sridhar SM, Assistant Professor, Department of Electrical and Electronics Engineering, BITM Ballari. In this video, we'll discuss about gauge factor, Poisson's ratio, properties of gauge materials, and adhesive techniques. First, we'll discuss gauge factor. When a strain gauge is subjected to a positive strain, its length increases while its cross-sectional area decreases. The resistance of a conductor is proportional to its length and inversely proportional to its area of cross-section. So it can be given by the equation R equal to rho L by A. The resistance of the strain gauge increases with the positive strain. The change in the value of resistance of strained conductor is more than what we can be accounted for the increase in resistance due to dimensional changes. The strain gauges are commonly used with the Wheatstone bridge circuits to measure the change of resistance of a grid of wire for calibration purposes. The gauge factor is defined as the ratio of relative change in electrical resistance to the change in length. It is also called as strain factor, and it is given by the equation GF equal to delta R by R divided by delta L by L. Rearranging this equation, we get 1 plus 2 micron plus delta rho by E, where R is unstrained resistance of a strain gauge, delta R is corresponding to the change in resistance R, E is strain, this is a mechanical strain, which is delta L by L, where delta L is change in length per unit and L is the length of the wire, mu is Poisson's ratio, and rho is the resistivity. In the above equation, the first term 1 represent the resistance change due to the change in length. The second term 2 mu represents the resistance change due to the change in area. The third term represents resistance change due to change in piezoresistive effect. Strain is usually expressed in terms of microstrain, where 1 microstrain is equal to 1 micrometer per meter. In the above equation, when change in resistivity due to the strain is a lesser value and is neglected, the above equation can be rearranged as gauge factor equal to 1 plus 2 mu. So by this above equations, so we can identify the gauge factor. Next, we'll discuss about the Poisson's ratio. Poisson's ratio is a measure of Poisson's effect that describes the expansion or contraction of a material in directions perpendicular to the direction of loading. And the value of Poisson's ratio is a negative of the ratio of transverse strain to a axial strain. For smaller values of these changes, Poisson's ratio is the amount of transversal expansion divided by the amount of axial compression. Most of the metals have Poisson's ratio values ranging between 0 and 0.5. Next, we'll discuss about the properties of gauge materials. The grid material for proper functioning should have the following desirable properties: high resistivity and high gauge factor, should have high mechanical strength, and it should have high electrical stability, low temperature sensitivity, low hysteresis, low thermal EMF, good corrosion resistance, and good weldability. So these are the properties of gauge materials. Next, we'll discuss about adhesive techniques. For proper mounting of a strain gauges, the following steps should be followed. The first step, before mounting the strain gauge on a surface, the surface must be preferably cleaned by emery cloth and base material exposed. Second step, remove various traces of oil or grease and etc. by using solvent like acetone. Third step, swab the back of the strain gauge by cotton dipped in acetone to ensure that the back is free from any contamination. Next step, apply enough cement to the cleaned resistance and place the clean gauge on it. Make sure that there is no bubble between the surface and the gauge. If is there, that should be removed. Avoid using heavy pressure, otherwise cement may be puncture the paper and short the grid. Next step, allow the gauge to sit for at least 8 or 10 hours before using it. If possible, a slight weight must be placed by keeping a strong rubber on the gauge. The next step, after cement curing, check the connectivity of a wire by an ohm meter and weld the electric leads. So these are the mounting techniques to be followed when a strain gauge is being mounted. Thank you.